Hello everyone, my name is Nehati from Sri Venkateshwara College of Engineering, bearing DSN 1V22 CS100. Today I am here to speak a few words on the topic electrode system. So without any further delay, let's get into the video. The agenda for today is that first of all, we'll be discussing what is electrochemistry, then we'll go to electrochemical cells. We'll learn the types and reactions in electrochemical cells. We'll go ahead with electromotive force, that is EMF, and then electrode potential, and then finally, we'll be winding up with standard electrode potential. What is electrochemistry? Electrochemistry is basically the branch of chemistry which deals with the interrelation or interconversion from electrical energy to chemical energy and chemical energy to electrical energy. And this conversion happens only because of redox reaction. What is redox reaction? Redox reaction is nothing but a reaction in which there's oxidation and reduction taking place simultaneously. There are some chemical changes which happens only with the help of electricity, and there are some chemical reactions which produce electricity. So these two types of reactions come under electrochemistry. What are electrochemical cells? Electrochemical cells are nothing but they are the cells or devices which works on the basis of electrochemistry. So going by the definition, we can say that it is the device used to generate electrical energy from chemical reactions occurring in it or to use the electrical energy supplied to it to facilitate chemical reactions. They are capable of converting chemical energy into electrical energy and vice versa. So this is nothing but it's just the cells or devices which works on the basis of electrochemistry. So the important reactions in electrochemical cells, there are two reactions, that is the oxidation reaction and the reduction reaction happening to bring about the electrochemical change in a reaction. So the first one will be going with oxidation reaction. What is oxidation reaction? Oxidation reaction, in oxidation there are important reactions in an electrochemical cell. We just said that electrochemical cell base works on the basis of redox reaction, and in redox reaction oxidation and reduction happen. So first of all, we'll be going ahead with oxidation reaction. In oxidation reaction, there's loss of electrons. The metal gives oxidizes into a metal ion and it liberates some number of electrons. This number of electrons that is liberated is based on the metal used here, and there is increase in the oxidation number in oxidation. Coming to reduction, it is the total opposite of oxidation reaction. In reduction, there's gain of electrons. The metal ion gains the number of electrons, gains some number of electrons that is liberated and forms a metal. The total opposite of oxidation reaction is reduction, and there is also a decrease in the oxidation number in reduction. Types of electrochemical cells. We have two types of electrochemical cell. First one is the galvanic cell, and the second one is the electrolytic cell. In galvanic cell, chemical change converts into electrical changes, and in electrolytic cell, electrical changes convert into chemical changes. We'll not be dealing with electrolytic cell here. We'll just be going ahead with galvanic cell. And there's another type of electrochemical cell, that is the concentration cell. In a concentration cell, it is the electrode and the electrolytic solution. Both are of the same type, but they're different in concentration. So that is concentration cell. We'll not be dealing with electrolytic and concentration cell. We'll just be learning about what is galvanic cell, their working, construction, reaction in this video. Galvanic cell. The best example or an example for galvanic cell is the Daniell cell. We have learned about galvanic cell in our previous classes also. So first of all, going with the construction of galvanic cell. The galvanic cell consists of two half cells. There are two containers, and in these two containers, there are electrolytic solutions and two electrodes. The electrode and electrolytic solution in one container is of the same metal, and these two half cells are connected externally using a voltmeter or a bulb. Here, voltmeter or a bulb is just to show the production of current or the production of electricity. The movement of electrons produces electricity, and to show this electricity production, we use voltmeter or a bulb, and this is connected using metallic wire. Internally, the half cells are connected using a salt bridge. In the salt bridge, we use inert electrolytes such as KCl, K2SO4, KNO3, etc. We use inert electrolytes so that it doesn't interfere with the reactions happening in the two half cells. Coming to Daniel cell, in the two half cells, the first one is the zinc half cell and the another one is the copper half cell. In zinc half cell, we have the zinc electrode dipped in zinc sulfate solution, and in the copper half cell, we have the copper electrode dipped in copper sulfate solution. They are separately known as half cell, and together they make a complete cell. A salt bridge between them connects the two half cells. As I said, it is internally connected to the two half cells using a salt bridge and externally by a bulb or a voltmeter. In anode, coming to the working of galvanic cell, in anode there is oxidation taking place. In anode, always oxidation takes place, and in cathode, always reduction takes place. Here, the zinc half cell is the oxidation half cell, and the copper half cell is the reduction half cell. So oxidation, we know that the metal oxidizes into its metal ions and liberate electrons. So in zinc half cell, what happens is the zinc electrode is oxidized into Zn2 plus and it liberates two electrons. These two electrons passes through the metallic wire and produces electricity. It goes to the cathode, that is to the Cu2 plus ions, which is in the copper sulfate solution. It combines with the Cu2 plus and forms copper. This copper is deposited on the copper electrode. The movement of electrons is shown down in the video. The electrons are moving from the zinc electrode to the copper electrode, and this produces electricity. Coming to the working, we just learned about the working over here. We'll just read what is given in the PPT. Zinc ions from the zinc electrode goes into the zinc solution. At zinc electrode, oxidation takes place. Where oxidation takes place, we term it as the anode. So zinc half cell is the oxidation half cell or the anode. It is usually placed on the left side. From our point of view, we place it on the left side, and the cathode, we place it on the right side. So at cathode, what happens? Cu2 plus reduces to Cu. It takes the two electrons coming from the zinc. Zinc liberates two electrons, and copper ion Cu2 plus takes up the two electrons and forms copper, and this copper is deposited on the copper electrode. So what happens in this is zinc keeps oxidizing and zinc's electrode's size becomes smaller and copper increases in size. At Cu, electrode reduction takes place, hence it is the cathode. It is usually placed on the right side. Coming to the reactions. Reaction at anode, we can see that zinc is oxidized into Zn2 plus and liberate two electrons. Reaction at cathode, copper takes Cu2 plus, that is the copper ions, takes up the two electrons that comes from zinc and it forms copper. Net reaction, if we have to say, we can say it as zinc in solid state plus Cu2 plus in aqueous state gives Zn2 plus in aqueous state plus Cu, that is solid. Salt bridge. We said that salt bridge is the internal connection of within the two half cells. So what is salt bridge we'll be learning and what are the functions we'll be seeing now. Salt bridge is composed of strong electrolytes like potassium chloride. We use strong and inert electrolytes like potassium chloride. We can take K2SO4, we can take KNO3, etc. Inert electrolytes are used so that they doesn't interfere with the reactions of the half cells. We can see in the picture here that KCl is used in the salt bridge. What happens here is K plus, it divides and gets separated into K plus and Cl minus, and this Cl minus. When in zinc electrode, what happens? We know that Zn2 plus keeps getting produced, and there is a positive charge formed around the zinc electrode. And in copper, there is SO4 2 minus keeps forming, and the surrounded area is negatively charged. So what happens is the Cl minus comes and joins with the Zn2 plus and forms zinc chloride. And the same happens at K plus, potassium ion goes on with the SO4 2 minus and forms K2SO4. This happens so that the reactions does not stop and there's continuity in the reactions. So We can say a solvent is used to maintain electrical neutrality that we just said inside the circuit of a galvanic cell. Next, we can say solvent acts as an electrical connection or an electrical and internal connection between the two half cells. Next, a solvent prevents diffusion of solution from one cell to another. We just read about that. Coming to electromotive force, what is electromotive force? Electromotive force, we can say it is the EMF of a cell. The maximum potential difference that exists between two electrodes of a cell is defined as EMF of a cell. What is the maximum potential difference that exists between two electrodes? There's a potential difference created between the two electrodes, and this potential difference is nothing but it is termed as the electromotive force. We can write the reaction for this as E cell is equals to E cathode minus E anode. Remember it. We can also say it as E cell is equals to E right minus E left. It is nothing but E cathode minus E anode. This is also known as the net voltage between oxidation and reduction half cells. E cathode is the oxidation half cell, E cathode is the reduction half cell, and E anode is the oxidation half cell. Electrode potential. The potential at the interface between the metal and its own ionic solution, it is electrode potential. What is electrode potential? There's a potential difference created between the interface of the electrode and the electrolytic solution of its own electrolytic solution. So this is electrode potential. What is standard electrode potential? It's nothing but the electrode potential in the standard unit values. As we can read the definition there, potential at an electrode when all the substances involved in reactions are in their standard state. What are the standards say? Solutions are 1 molar concentration, gases at 1 atmospheric pressure, and everything is at 298 Kelvin. This is standard values or standard states. And when all these are in the standard state, we can see that it is standard electrode potential. So this is all for today, and what we've learned in this session, we learned about electrochemistry. We learned what are electrochemical cells, types of electrochemical cells, reactions involved. We learned about what is galvanic cell, its working, construction, reaction. Then we came to EMF, electrode potential, and standard potential. So this is all about the video. I hope you all enjoyed and learned something from this. Okay, so I would like to end this video here. Thank you so much for spending your time with me.